तब तक एडजस्टमेंट करिए, थोड़ा
बस अभी
डिस्कशन
तो
कर लेता हूँ।
नहीं, हो गया
प्रीवियस सेशन और दिस सेशन के लिए।
1 मिनट ठहरिए। She's there, she's online. Monica, you're online, na? Just a minute.
Yes, ma'am. Yes, ma'am.
Yeah. Just a minute, huh?
Okay.
Start. Start. It's already on. It's already online. Sir, already live stream हो रहा है.
Can I share my screen, ma'am?
No, just wait. We'll just start.
Okay.
Just
Okay.
शुरू कर दो। Just now before PDF, we had a good session on astrophysics, discussing with so many doctors and scholars. Now we are moving for the next session, cosmic and space physics. For this, to initiate this session, I would like to call Dr. Rafi Turab, professor in physics, School of Physics, Mono. Continue and discuss about this session. So please actually Rafi Turab sir. The next session is started by the title of the next session is Assessment of Environmental Gamma Radiation from Survey Meter and TLD by Dr. Monica S. Online session. So, madam.
Good evening.
Yeah, Monica, you can share.
Okay, madam. Okay. Good evening to all. I am Monica S. from St. Joseph College for Women, Alappuzha. Can I share my screen,
Yeah,
ma'am?
yeah, please do.
Okay.
Yeah, Monica, are you sharing?
Yes, ma'am. 1 minute.
Yeah.
Ma'am, I cannot host a disabled participant screen sharing. Ma'am,
Actually, the problem is you are twice logged in, no? Okay. Now try.
Ma'am, can you share?
Right, now you are doubly co-host. Now you can share.
Okay, ma'am. Okay. Yes, ma'am. Yes.
You had 2 logins, no? That
Okay. Yes, correct. One minute. One minute.
Yeah. Okay.
That's no department final presentation. My research topic is assessment of environmental gamma radiation from TLD and survey method.
1 minute. Okay, just a minute.
Okay.
1 minute. Sorry. 1 minute. Yeah.
1 minute. Okay. My topic is assessment of environmental gamma radiation from survey meter and TLD. Here we know that radiation is an energy which easily penetrates into matter. The radiation is classified into ionizing and non-ionizing. Ionizing radiation means highly penetrating radiation, and non-ionizing means it have low energy enough to penetrate through matter. There are 3 important pathways in which ionizing radiation enters into human body: through inhalation, through ingestion, and externally gamma dose. Here in my work, I find out the annual effective dose enters into human body externally. Here I use 3 methods. First one, soil analysis, and the second one, I measure the terrestrial and extraterrestrial radiation by using survey meter at TLDR. Here, the survey meter is an active measurement. We will directly obtain the terrestrial and extraterrestrial component directly by using survey meter. And second one is TLD. It is a passive measurement. We need at least 3 months to obtain the correct result. And the third method is gamma spectrometric analysis. Here, this is an analysis done by using soil analysis. And here, by using this measurement, we obtain the terrestrial component, only the terrestrial component, that is radium, thorium, potassium, measurement of the soil samples. Here in my work, I obtained the work along the coastal region of Kollam, Thiruvananthapuram, and some region of Alappuzha. These are some of the coastal regions of Kerala. These are important results: indoor and outdoor gamma dose rate, which measured using survey meter and TLD. These include these all values are compared with the Indian average and the world average value, but in certain places I obtain the gamma dose rate above the Indian average values, certain high values, but it does not too much affect the human body. Gamma dose rate only affect the externally, that is skin part only. Which is this is a comparison of annual effective dose of different locations, which were compared with the world average and Indian average values. The correlation is also drawn between survey meter and TLD. I obtain a good correlation between survey meter reading and the TLDs. Also, the soil sample measurements was also done. About 250 soil samples are collected along this area and find out the concentration of radium, thorium, and potassium of the soil samples. From the terrestrial and the extraterrestrial radiation, from the correlation plot, I also obtained the cosmic ray component of this rays. The important conclusion: the mean value of dose rate are lower than the world average and Indian average value. Also, a good correlation was observed between the gamma dose rate measured using survey meter and the TLD. Yes, ma'am. One minute, ma'am. 1 minute. Okay. Conclusion. Ma'am, it is visible. Ma'am, it is visible.
Yes. And go and screen slideshow box. Yes, right. Yes, right. Okay, it's okay. Conclude.
The annual effective dose in most of the soil samples is below the safe limit. Ma'am, it is audible.
It's audible, ma'am. Please proceed.
Okay, ma'am. These are the important conclusion. The annual effective dose in most of the soil samples is below the safe limit. Also, the average cosmic dose component is 39 nanogram per hour. which is comparable with the world average and Indian average value. Okay, ma'am. Thank you.
Any question?
Okay, ma'am. Okay,
Thank you, ma'am.
thank you, ma'am.
Thank you, Dr. Monica.
Yes, sir. Yes, sir.
Very good.
Thank
Close the session. So the next session will be given by next participant is effect of super cyclonic storm.
Yes, yes, sir.
Yeah. Dr. Monica, you can
Can
share.
I stop share, sir?
Yeah. Stop sharing.
Okay. Thank you.
The next topic title is effect of super cyclonic storm Amphan on the low latitude atmosphere ionosphere system by Dr. G.J. Bhagwatamal online.
Visible to on. May I audible, sir? Okay, 1 minute. Is my slides visible? Yeah, yes, ma'am. Slides are changing.
It's changing.
Yeah.
It's changing.
Yeah, yes.
But carry on. You can start this session.
Okay. So good evening, one and all, and thank you for the opportunity for presenting my results in this national seminar on current advances in the applied physics. And the title of my presentation is Effect of Supercyclonic Storm Amphan on the Low Latitude Atmosphere Ionospheric System. So in this case, we have in this study, this work is published in a peer-reviewed Journal of Atmospheric Solar Terrestrial Physics, and which is a collaborative work with the NICT Japan. And so as we know that tropical cyclone is a severe meteorological phenomena which can produce a severe damage and economic loss and human hostilities in the environment. So as we know that this growth of cyclone is categorized into based on the increase of the maximum sustained surface wind. So we can say it's a low pressure if the wind speed is very low, greater than 70 knots, and depression, and then deep depression, cyclonic storm, severe cyclonic storm, very severe cyclonic storm, and super cyclonic storm. So this is the growth, how the cyclones are growing and the evaluation of the cyclone. And so how we know that how there are the recent days we are getting an increased number of tropical cyclonic events, as well as the intensity of the cyclonic events is also increased. So what will be the cause for this, and what kind of changes or effects which can introduce on the atmosphere ionosphere system? So so there are a few decades, there are a lot of studies have been done in connecting with the tropical cyclone ionospheric research using utilizing state-of-art ground-based observations like GPS, GNSS, VLF, and ionozone observations. So the summary, some of the summary of the conclusion is variation in the total during the cyclonic storm, that the cyclone severely affects the total electron content, which is in the ionospheric electron concentration, that will be greatly affected by the cyclone. And also when the cyclone is there, which induces the gravity waves, which the gravity wave oscillations can be seen in the ionospheric region. And whereas when we using the VLF signal transmission, there is a change in the VLF signal, either in the positive or negative anomaly form. And then the critical frequency of the F2 layer is either decrease or increase depending on this. So these kind of variable results will be seen in several years. And the reason is one of the reason is the ionosphere, which greatly affects our radio communication. So how the tropical cyclone affects the ionospheric region, and this will give you a clear mechanism between the tropical cyclone and the ionospheric coupling mechanism. So in Vienna DAT 2018, they proposed a two-way mechanism, because as we know that ionosphere is a plasma ionized layer which has a neutrals as well as ions, and it is influences both. It's like a sandwich kind of layer which affects due to the forcing from the upper atmosphere as well as the forcing from the lower atmosphere. When we take forcing from the upper atmosphere, we can say sun and that magnetosphere, effect of geomagnetic storm, these kind of effects which can influence ionospheric process. Similarly, when we have a lower atmosphere, as we know that the weather phenomena or whatever the meteorological process which can introduce dynamically, which can affect the ionospheric region. So there is a two-way coupling mechanism. One is a dynamic coupling, another one is a electrodynamic coupling. So in this study, we utilize the data from a variety of sources like ionospheric observation from Celian network, and we collected the cyclone report and data from the Indian Meteorological Department, New Delhi, and outgoing long wave radiation from the NOAA, National Oceanic Atmospheric Administration, and ECMWRF reanalysis, which we have seen that what kind of whether is there any geomagnetic disturbance or disturbances due to the upper atmosphere is there, that we collected KP index as well as DST index, which will give you that whether the upper atmosphere is quiet. Then whatever the forcing what we report in the ionosphere, that will due to the purely due to the lower atmospheric forcing. So these are the data we collected. There are certain methodologies we applied. We applied a spectral analysis, FFT filtering, and we used wavelet analysis in order to retrieve the frequency component, dominant wave modes, and then we used some statistical methods to find the anomalies which is present during the cyclonic period. And Chiming, which is the ionozone station, ionozone observatory, which is located in the Celian network, which is away of Amban cyclone is away from the Amban cyclones of 13 degree approximately. And when we take Amban, the event which happened on 16th May 2020 to 21st May 2020. So the top panel of the figure shows the distance between the separation between the cyclonic position and the ionozone observatory. You can see that when the cyclone moves to in the Bay of Bengal region, the distance is gradually decreasing. And the bottom panel of the diagram shows the shows the surface variability, like how this central pressure decreases during the growth of a cyclone, and also the maximum sustained wind variation during the growth of cyclone. So you can see that there is a pure exactly anti-correlation between the central pressure as well as the maximum sustained wind, and the peak activity is observed in 18th May 2020. Yeah. And we check the upper atmospheric condition, whether they are quiet, so that we can confirm that whatever the features observed in the ionosphere, that is due to the lower atmospheric process. So we checked with the 3 hours KP index as well as DST index, which tells you the KP is less than 3 is a quiet condition, as well as DST is also within the limit. There are small, not much significant variation. So so we check that the event is a geomagnetic, the duration what we take, that May month is a geomagnetically quiet period. And we took the FOF2, that is the critical frequency of the 2 layer, and the black line shows, we can say the FOF2 variation during day and night time throughout the cyclonic period, as well as the post 1 week of the cyclonic period. You can see the top panel as the FOF2 variation for the both in the day and night time, and the bottom panel shows the FOF2 variation for the daytime alone. And the period May 16 to 21 covers the Amban cyclonic period, then May 22 to 28 covers the post stage of the cyclone, and the black line describes the reference level. So we took a prior of 1 week that we consider as a reference level, that reference ionospheric variation, FOF2 variation. So we plotted that, and what is happening during the cyclonic period. We can see that on 18th, 17th, 18, 16, 17, 18, throughout the cyclonic period, there is a suppression of FOF2 frequency, FOF2 critical frequency, when we include both daytime and nighttime. And even if we include only daytime also, that the feature is very significant, that the strong suppression of critical frequency FOF2. And similarly, when we take a HMF2, we can see a increase, elevated modulation. Some days we are getting an increased one, some days we are getting a decreased variation of HMF2 during the cyclonic period than the prior region. So we can observe that there is a strong modulation in the FOF2 variation between the 0 and 6 hours during the cyclone period.
Excuse me, ma'am. Can you conclude, please?
Yes, sir.
Go for conclusion.
Conclusion.
Yes.
So we can see the sudden drop in the frequency, critical frequency, nearly approximately 1 megahertz. And we did outgoing long wave radiation to see the convective activity. You can see a strong convection during the cyclonic period, and the vertical velocity wind, negative vertical velocity wind shows there's a strong upwelling of the winds, which indicates a strong convection. And the background wind, what we have seen in the stratospheric heights as well as in the mesospheric winds, which shows a weak westward winds observed in the stratosphere, and westward as well as strong eastward as observed wind is observed over the mesospheric region. And when we did the wavelet analysis, we found that there is a 2 to 5 hours gravity wave oscillations are observed in FOF2, HMF2, as well as in the case of stratospheric, as well as in the precipitation also. So this confirms that there is a strong the coupling between the lower atmosphere as well as the ionospheric region. And during the cyclone, we could see a strong decrease of about 1 megahertz in FOF2, as well as a modulator HMF2. And that the intensity is very strong during the severe cyclonic stream as well as the landfalling case. And also the maximum suppression has happened in the noon time, and during the cyclone there is enhanced convection has happened, and also that background which is favors the propagation of the gravity waves, and which interacts with the ionosphere and decreases the electron content. So this suggests that the TC-induced gravity wave propagation introduces significant modulation in the ionospheric FOF2 and HMF2, which confirming again that there is a strong connection between the tropical cyclone and the ionosphere. And I acknowledge there are several data providing agencies, and I acknowledge the Center for Research from our university for granting a research fellowship grant. Any questions? Thank you for the opportunity.
Thank you, madam. So Dr. Bhagwati Ammal has given a presentation on effect of cyclones on ionosphere. Do you have any questions on this? Madam?
Yeah, yes, sir.
Can you go back for the previous slides, madam? I have a doubt that you have given one spectra. This one, zonal spin. So you have taken this zonal spin at 37 kilometers.
Yes, sir.
And but whereas ionosphere is more than above than.
No, we took 300 kilometer FOF2 concentration, FOF2. Because these gravity waves are high energetic waves which can propagate and which can introduce affect the ionospheric F2 region even up to 300 400 kilometer.
So how can you conclude that this lower stratosphere, lower troposphere effect on
no, we can see in the precipitation there is a strong convective gravity wave oscillation is observed with 2 or 6 hours oscillation that propagates stratosphere as well as mesosphere, because the background is favors for the propagation, and finally it can see the features in the ionosphere.
Thank you, madam.
Thank you.
Very nice presentation.
Thank you, sir.
Okay, thank you, madam. You can close, madam.
Yeah, thank you, sir.
The next participant topic is a comparative study on air pollutants collected from different locations of Hyderabad and Kadapa using CPCB data by Syed Altaf Ahmad. Please on the stage.
Bismillahirrahmanirrahim. Assalamu alaikum. Welcome to National Symposium on Current Advances in Physics, organized by Department of Physics, SOS, Maulana Azad Urdu National University, Hyderabad.
Madam, slides can continue. इसी से होगा, एक मिनट, एक मिनट, ये जो बटन है
I am Sayyid Altaf Ahmed, currently doing a PhD under the Alim Basha sir and course supervisor Dr. Shoaib sir. I want to give presentation on a comparative study on air pollution, air pollutant collected from different locations of Hyderabad and Kadapa using CP/KB data. What is meant by air pollution? Air pollution is nothing but the contamination of the air by chemical, physical agents and biological agents that alter the atmosphere natural characteristics. What are the sources of air pollution? That are vehicle emissions, power generation, industrial emissions, agriculture emissions, cooking emissions. That effect on global warming, acidic rain, premature death, heart diseases, lung cancer, and respiratory diseases. Major air pollutants are characterized by different techniques that are PM 2.5, PM 10, SO2, NO2, NOx, NH3, CO2, CO, and O3. The AIQ data range is given by AIQ 0 to 50 means good, 51 to 100 moderate, 101 to 150 unhealthy for sensitive group. Sensitive group means the children and pregnant women. 151 to 200 is unhealthy, 200 to 1 to 300 very unhealthy, and 300 1 to 500 hazard. मतलब India is at third most polluted country, while Hyderabad is the fourth most polluted city in India. To counter the air pollution, we study and analyze it by using Central Pollution Control Board data. For the comparative study, we collected 10 days pollution data from Kadapa, Yoramukopalli, and Hyderabad, Sanatnagar, Bularam, Paranchuru, and Central University, Hyderabad at evening time in traffic hours. That gives the result according to the data. Here you can see the dates which are taken and here the air pollutant which are characterized by the CPCB data at Kadapa, Yoramukopalli, PM 2.5, PM 10, NO2, SO2, CO3, NH3. While NH3 is absent in the atmosphere of Kadapa, Yoramukopalli. While we characterize in Hyderabad, Sanatnagar, then PM 10 is absent here, and PM 2.5 to PM 2.5 is at peak level. Bularam, it is have like that data. This is the data of Patancheru, and this is one Central University, Hyderabad. After that, we average them with Yoramukopalli, then the data is given like that. Here PM 2.5 is the highest in Kadapa region, Yoramukopalli. While NH3 is absent here, and average of all locations of Hyderabad, Sanatnagar, Bularam, Parancheru, SQ, and we will make it average. Then we got the PM 2.5 is a major air pollutant dominant in the atmosphere of Hyderabad. Then the comparative graph is here between the Yoramukopalli, Kadapa, and Hyderabad. Then we got from the data PM 2.5, PM 10, and all the data is much higher than in Kadapa. In Hyderabad, atmosphere is in a highest in the peak level as compared to Yoramukopalli, Kadapa. From the conclusion, comparative graph, it is evident that the metropolitan city such as Hyderabad exhibits higher pollution level compared to the urban cities like Kadapa. Notably, PM 2.5 and PM 10 emerge as a dominant air pollutant in both Hyderabad and Kadapa regions. Interestingly, ammonia concentrations are comparatively lower in Hyderabad compared to Kadapa. Moreover, our finding indicate that the Nagar experiences particularly high pollution levels, especially concerning PM 2.5, surpassing other than other regions of Hyderabad. The PM 2.5 concentration at Nagar is standing at 175, categorize it as an unhealthy region, likely attributed to its industrial zone. Thank you.
Any questions from students? So what is the difference between and 190? What is that number?
Particulate matter है,
हाँ।
particulate fine particle.
और स्लाइड्स में आपको पीछे पेज जाकर क्लियर से डिस्कस करूंगा क्या है ये 120 100 पीछे और पीछे आओ। हाँ राइट, यहाँ पर जो 72 78 65 है वो क्या है वो?
ये एक्चुअल में AIQ डेटा है, एक्चुअल में पॉल्यूशन लेवल वहाँ का मौजूद जो है अवेलेबल सेंट्रल पॉल्यूशन कंट्रोल बोर्ड के डेटा के अंदर अवेलेबल है। एक AIQ रेंज है, उसका यूनिट नहीं है, जैसा कि यहाँ पर इससे पहले ही बता दी हम AIQ रेंज ये हुआ है। ये रेंज है जिसको वहाँ पर एस्टेब्लिश किया। थैंक यू।
Right, nice presentation by Syed Altaf Ahmad. The next presentation is a comparative study of lifted index, precipitable water, air pollutants, and rainfall over Hyderabad by Mohammad Tayyib. Please be on that.
Assalamu alaikum. My name is Mohammad Tayyab, research scholar, physics section, School of Science, Maulana Azad National Urdu University, Hyderabad. My title is A Comparative Study of the Lifted Index, Precipitable Water, Air Pollutant with Rainfall over Hyderabad. My supervisor is Dr. Rizwanul Haq Ansari sir and co-supervisor Professor S. Alim Basta sir. So plan of the talk, general introduction, lifted index in this way. So when atmosphere is stable, then vertical air mixing is low, and when atmosphere is unstable, then vertical mixing is high, more than convection. Then एयर पॉल्यूटेंट किस तरह से रिलेटेड है एटमॉस्फेरिक स्टेबिलिटी से। तो हमारा एम ये है कि एटमॉस्फेरिक स्टेबिलिटी इंडेक्सेस हमने सिलेक्ट किया लिफ्टेड इंडेक्स, जिसको कंपेयर करना है एयर पॉल्यूटेंट कंसंट्रेशन से ओवर हैदराबाद। तो व्हाट इज द स्टेबिलिटी ऑफ द एटमॉस्फेयर? Lifted index, it is the instability indices which indicate stability of the atmosphere. The calculation of the lifted index in this equation, Li equal to T minus T. T is the environmental temperature at 500 SPA and T star is the air partial temperature at 500 SPA. When we calculate, then इसकी वैल्यू Li की वैल्यू हो सकता है पॉजिटिव या निगेटिव। So based on Li values, we identify atmospheric stability. If Li value is more than 0, then it indicates atmosphere is stable. When its value is minus more than, suppose minus less than -9, then it indicates extremely unstable. So this is the calculation of lifted index an SQT chart. This is the thermodynamic diagram. So here जब वीदर बैलून जैसे जैसे ऊपर जाता है उसके रिस्पेक्ट में टेम्परेचर, रिलेटिव ह्यूमिडिटी, प्रेशर, ये सारी चीज़ें चेंज होती है। उसके रिस्पेक्ट में यहाँ पर ग्राफ दिखाया गया, जैसे कि ग्रीन से ड्यू पॉइंट टेम्परेचर, हेयर ड्यू पॉइंट टेम्परेचर का वेरिएशन, TP is the air parcel temperature variation and this is the environmental temperature variation. So lifted index calculation at 500 HPA. So here at 500 HPA, environmental temperature and air parcel temperature. तो यहाँ पे जो ये थर्मोडायनेमिक डायग्राम है, इसमें टेम्परेचर की जो लाइन है स्क्यू वर्टिकली ये ब्लू कलर से इस तरीके से, तो यहाँ पर हमने उस लाइन के पैरेलल में कैलकुलेट किया इन्वायरमेंटल टेम्परेचर और पार्शियल टेम्परेचर। तो हियर LI values is negative, so it's indicate atmosphere is unstable. Next case, when lifted index value is positive, it indicate atmosphere is positive at 500 HPA, partial temperature, environmental temperature. So we calculate lifted index plus 10. So it indicates atmosphere is positive. Next parameter is precipitable water. Precipitable water is a humidity parameter. The calculation इस तरीके से होता है, जैसे कि ये मेजरमेंट करता है कि एटमॉस्फेयर में टोटल अमाउंट ऑफ वाटर वेपर कितना है। अगर हम अर्थ की सरफेस से एक वर्टिकल कॉलम इस तरीके से ऊपर ड्रॉ करें तो जितना भी अमाउंट ऑफ वाटर वेपर है वो ऊपर कंडेंस हो करके अगर इसमें फिल होगा तो इसकी जो डेप्थ होगी, दिस इज द प्रेसिपिटेबल वाटर। हियर इट इज द फार्मूला, x इज द टोटल एटमॉस्फेरिक मिक्सिंग रेशियो। तो x की वैल्यू कैलकुलेट करने के लिए वेपर प्रेशर, टोटल प्रेशर, वेपर प्रेशर टेम्परेचर के रिस्पेक्ट में डिफरेंट होता है। जैसे कि यहाँ पे टेम्परेचर 20 डिग्री सेल्सियस, तो यहाँ पे टेम्परेचर की वैल्यू रख के हम वेपर प्रेशर कैलकुलेट कर सकते हैं। वेपर प्रेशर की हेल्प से मिक्सिंग रेशियो यहाँ पे कैलकुलेट हो जाएगा। तो डिफरेंट टेम्परेचर के रिस्पेक्ट में मिक्सिंग रेशियो, हियर मिक्सिंग रेशियो ग्राम पर केजी, डिफरेंट टेम्परेचर पे मिक्सिंग रेशियो। तो कैलकुलेशन इस तरीके से होता है। तो यहाँ पे प्रेसिपिटेबल वाटर जो मेजरमेंट करता है टोटल अमाउंट ऑफ वाटर वेपर इन द एटमॉस्फेयर। नेक्स्ट इज एयर पॉल्यूटेंट। हमने यहाँ पे एयर पॉल्यूटेंट पार्टिकुलेट मैटर 10, पार्टिकुलेट मैटर 2.5, कार्बन मोनोऑक्साइड, NO2, SO2 और O3 को सिलेक्ट किया है। कंपेयर करने के लिए व्हेन एटमॉस्फेयर स्टेबल है तो इनका कंसंट्रेशन कितना है और अनस्टेबल है तो इनकी कंसंट्रेशन कितना है। एयर पॉल्यूटेंट डेटा हमने यहाँ से यूज किया। दिस इज द वेबसाइट लिंक, दिस इज सोर्सेज ऑफ एयर पॉल्यूटेंट और इसका साइड इफेक्ट। दिस इज द डेली वेरिएशन ऑफ एयर पॉल्यूटेंट कंसंट्रेशन डेटा हियर इन द मंथ ऑफ जून, जुलाई, अगस्त, सितंबर। दिस इज द साउथ वेस्ट मानसून सीजन। इन दिस सीजन more than convection and amount of water vapor more, then precipitation ज़्यादा होती है, बारिश ज़्यादा होती है, तो उसके दौरान एयर पॉल्यूटेंट कम है। यहाँ पे 0 से 50 गुड, तो कंसंट्रेशन इस सीजन में कम है सभी ग्राफ में। दिस इज द डेली वेरिएशन। तो रेनफॉल से भी हम कंपेयर करेंगे। रेनफॉल जब टेम्परेचर अर्थ की सरफेस पे टेम्परेचर हीट होगा तो वाटर वेपर होगा, उसके बाद कंडेंसेशन के बाद वेपर। दिस इज द प्रोसेस ऑफ रेनफॉल। हमने यूज किया है प्रेसिपिटेशन रेनफॉल डेटा को इंडिया वाटर रिसोर्स इंफॉर्मेशन वेबसाइट से। दिस इज द वेबसाइट लिंक। इस वेबसाइट पर 1901 से लेकर के अब तक आज की डेट तक डेटा अवेलेबल है। तो हेयर रिजल्ट, हमने जितने भी पैरामीटर हैं लिफ्टेड इंडेक्स, प्रेसिपिटेबल वाटर और एयर पॉल्यूटेंट और रेनफॉल का मंथली मेन डेटा कैलकुलेट किया फॉर 2019। So this is the result. When here it is the lifted index. When lifted index positive, it indicates atmosphere is stable. Then concentration of air pollutant is more, maximum. When lifted index is negative, it indicates atmosphere is unstable. amount of humidity parameter is more. Unstable means ज्यादा से ज्यादा कन्वेक्शन होगा, अमाउंट ऑफ वाटर वेपर बहुत ज्यादा होगा. यहाँ पे एक केस रेनफॉल के लिए जुलाई में रेनफॉल इज मैक्सिमम amount of humidity जो मेजरमेंट करता है प्रेसिपिटेबल वाटर इट इज द मैक्सिमम एंड लिफ्टेड इंडेक्स इज नेगेटिव. और इसके रेफरेंस में एयर पॉल्यूटेंट रेड कलर से दिखाया गया यहाँ पे इट इज लेस. सो रिजल्ट से पता चलता है कि इसका रिलेशन है. हमने कोरिलेशन कोएफिशिएंट को भी कैलकुलेट किया जो नेक्स्ट टेबल में है. दिस इज द रेनफॉल का एयर पॉल्यूटेंट से कोरिलेशन चेक किया. Yes, sir. Okay. So, we can conclude lifted index which is indicate of instability instability of the atmosphere. But we use as a indicator of air pollutant. हम एयर पॉल्यूटेंट को इसके बेस पे क्या प्रोबेबिलिटी होगी ये बता सकते हैं. तो दिस इज द रेफरेंसेस. थैंक यू. Any question, participant?
Thank you all. So here, today, we have conducted two groups of physics. One is related to astrophysics, which is far away from the Earth, and another group is atmospheric physics, which is little bit near to the surface of the Earth. These are the two different groups of people, and in this group, astrophysics is leading by our Professor Najam sir. You can take his advantage, complete information he is having, whatever knowledge he is having, you can take complete advantage from Professor Najam sir. And regarding atmospheric physics, it is leading in our university by Professor Alim Basha sir in physics. You can also take advantage for this atmospheric sciences. So I'll conclude this session. Very good. Thank you all.
So we come to end of this workshop. So tomorrow we are starting at 10 a.m. and physically it is in CSC auditorium, Civil Service Academy auditorium, and the online participants as usual you join with the